In modern warfare, seeing the enemy first is the only thing that matters.
Imagine a weapon you cannot see until it's too late.
It knows you are there before you even wake up. It watches you from the edge of the atmosphere.
It is the most expensive weapon system in human history. It is called the F-35 Lightning II, but to its enemies, it is simply a ghost.
How do you build a ghost?
To find the answer, we must enter one of the most secure buildings on Earth.
In a factory so large, it has its own weather. A mile-long cathedral of war, where science fiction becomes reality.
Welcome inside the secret factory.
Forget what you know about factories. There is no clanging metal here.
There is no smoke. This is the F-35 production line.
It spans 1.25 miles.
Every single day, thousands of workers and hundreds of robots perform a choreographed dance.
To build the most advanced machine ever made. The F-35 is not born in one place. It is a global Frankenstein.
Its tail is born in England.
Its wings, partially in Italy.
Its center in California.
But they all come here, to Fort Worth, to die and be reborn as one.
This is the critical moment. The mate.
In the old days, workers used sledgehammers and brute force to make airplane parts fit.
But you cannot hammer a stealth fighter.
If the skin is off by the width of a human hair, the stealth is broken. The enemy radar will see a gap.
Enter the EMAS, a system of lasers and sensors that measures thousands of points on the airframe. Before the parts even touch, a supercomputer performs a virtual mate. It simulates the connection digitally. The turbine blades are grown from a single crystal superalloy to survive temperatures that would melt lava.
Clearances look good on the starboard side.
Confirmed. Proceeding with final alignment sequence.
The process begins not with metal, but with carbon. Lightweight, durable, and crucial for stealth.
Robots perform the layup. They apply layers of carbon tape with precision lighter than a human hair.
A laser inspection system checks every layer. Even a tiny wrinkle could cause the part to fail at supersonic speeds.
To harden the skin, the parts are moved to the autoclave, essentially a giant pressure cooker.
Under immense heat and pressure, the soft tape fuses into a solid shell harder than steel.
While the skin is carbon, the skeleton is titanium. It's the only metal that can survive the structural loads.
These bulkheads are the backbone of the aircraft. They are carved from single blocks to eliminate weak points.
Titanium generates massive heat when cut. We use cryogenic cooling to keep the tools from melting.
We also use 3D printing to grow parts that are impossible to machine.
The tools used to hold the parts are massive engineering marvels themselves.
The F-35 is a global puzzle. It is built in 3 main sections by 3 different companies.
Lockheed Martin builds the forward fuselage, the cockpit, and the brain right here in Texas.
The center fuselage, housing the weapons bay and fuel tanks, arrives from Northrop Grumman. The aft fuselage and tail assembly are flown in from BAE Systems in the United Kingdom.
The wings are built separately. They are not just airfoils, they are wet fuel tanks.
UV inspection reveals cracks invisible to the naked eye.
Zero defects. A loose bolt here could destroy a $100 million jet.
Drilling carbon fiber is difficult. It splinters easily. Precision diamond-tipped bits are required.
This is the most critical moment, the mate, bringing the four sections together.
Lasers measure the alignment 100 times per second. The tolerance is less than half the width of a human hair. Slowly, the sections slide together. If they are misaligned, the stealth profile is ruined. Now, the empty shell must be filled. 15 miles of wiring are routed through the jet.
Hydraulic lines are the muscles, powering the flaps and landing gear.
The heart of the beast is the Pratt Whitney F135 engine, the most powerful fighter engine ever built.
The turbine blades are grown from a single crystal superalloy to survive temperatures that would melt lava.
Alignment confirmed, plus or minus 0.01.
Proceed with final insertion sequence.
For the Marine Corps version, a massive lift fan is installed, allowing the jet to hover. The nose is fitted with the AESA radar. It doesn't just scan, it can jam enemy electronics and hack networks.
Under the chin goes the electro-optical targeting system, a sapphire glass eye that sees heat.
Stealth requires weapons to be hidden inside. A bomber in a fighter's body.
The seat is the pilot's last resort. It can save them at 0 altitude and 0 speed. The canopy is coated in gold and indium tin oxide. This traps radar waves, hiding the pilot's helmet.
The aircraft enters the moving line. Like a car factory, the jets flow continuously toward the exit. The landing gear is installed. It must withstand the impact of slamming onto an aircraft carrier deck.
Weight on wheels. For the first time, the F-35 stands on its own legs.
Before it becomes stealthy, it turns green. This is the anti-corrosion primer layer.
Now, the jet enters the most secret part of the factory, the finishes facility.
Robots apply the radar-absorbent material. Nitty-gritty. The thickness must be perfect to the micron.
This isn't just paint.
It's a classified chemical matrix that traps radio waves.
The stealth coating is tested to survive heavy rain and storms. The anechoic chamber, a room with no echo, used to test the electronic warfare sensors. Every door has sawtooth edges. Straight lines reflect radar. Zigzags scatter it. The nozzle feathers help hide the heat signature from missiles. Fuel is also used as coolant, absorbing heat from the electronics. The entire aircraft is baked to cure the coating into a unified, radar-eating skin.
Jigs ensure every jet is identical.
The flight computer wakes up and flexes the jet's muscles.
8 million lines of code are uploaded. The F-35 is a flying server.
The most advanced part of the F-35 isn't on the plane. It's on the pilot's head.
This helmet costs $400,000.
The F-35 is covered in 6 hidden cameras. When the pilot looks down, they don't see the floor, they see the ground.
6 infrared cameras are embedded in the skin. They stitch together a 360-degree view for the pilot.
It fuses data from all sensors into one clear picture.
The helmet is connected. It projects the flight data directly into the pilot's eyes.
Explosives in the glass shatter the canopy before the pilot ejects. We blast it with radar to verify its signature. On a screen, it looks no bigger than a golf ball.
Construction is complete. The aircraft rolls out to the flight line.
Lockheed Martin test pilots are the first to trust their lives to the machine.
A final visual inspection. No scratches, no dents, no loose panels.
Engines start. The APU whines, followed by the deep roar of the main turbine.
Tower, Lightning 1 ready for departure.
Systems green. Hydraulics pressurized. Ready for takeoff.
Full afterburner. 43,000 pounds of thrust. Unleash.
From the factory in Texas, they are delivered to allies around the world.
The future is manned-unmanned teaming. This is how the future is made.
It takes 50,000 hours of labor to build just one. A reminder of who they are building for.
The F-35 Lightning II.